There we
It's going to
go.
be
Oh,
sent
it's right
to
there.
her because
Perfect.
she started the thing. Okay, dokie. I'm gonna move this up. Wrong thingy. Did it pop up anywhere?
Did it work? I did the approval.
I pressed OK.
All right, so don't know if it's working.
Oh, it's recording. I see
Okay,
the
it's
recording in the
recording
top
now. We're
corner.
good. Okay.
Oh,
All right. I didn't know that. It didn't say anything on my screen of like, you are now recording. Okay. All right. So I can start out with like the introduction. Hi, buddy. And then do the rationale and then talk about this engineering process. I have like our proposal off to the side that I'm gonna like glance at as I go through too.
cool.
Um but I'm also like going off this. Okay. All right. So
Works.
scene. Okay. All right. Hi, my name is Lillian Hardman. This is our engineering design process professional development proposal. I'll let the others introduce themselves.
Hi, I'm Imani Hollingsworth.
Hi, I'm Ryan Sells.
Okay. So we're going to talk a little bit about this engineering design process as we go. Our fourth person is going to add theirs to a separate file to turn in on their own because of prior situations. Okay, so why do we need to have this PD? So the engineering design process, this prepares our students for real world solving problems. They learn to communicate and to think critically amongst other peers. Using the whole STEM process, this subject naturally works together. They kind of flow in together or deal with one another. Kind of like how you need math with science, and science is kind of with math. They're kind of the same thing. And engineering is that math and science combination. So the engineering design process increases that student involvement or engagement with other core subjects. Okay, so with this engineering design process, there are specific steps. It's student-centered with this instructional framework. It encourages students to solve authentically, to have using creativity, collaboration, testing, and revision. So the steps are to ask, imagine, plan, create, test, improve, communicate. It's a lot of steps, but with this process, it kind of helps the flow of those students' critical thinking and having that authentic problem solving skill by identifying the problem, brainstorming, sketch your design, choose your materials that you're going to use, build your prototype, test out that material or that idea that they've got, improve where there might be any fault, and then communicate their findings or their results. Okay. So when we implement this, our teacher's role is really just to present that real world challenge to kind of set it up for the students. So that way they can do that investigation to design, test, analyze, improve, and present. But the whole key idea here is that students learn by doing rather than simply following directions. Okay. So it's that whole kinesthetic type learning where they're doing it on their own instead of having to sit there and look at instructions and having their hand held the whole time. Okay, so now we're going to move on.
So with being in different locations, we decided to go with the national standards. We chose for 2 math, 2 science, those being MP1, which is to make sense of the problems and persevere in solving them, meaning the students will analyze the challenge, determine possible solutions, and to continue improving the bridge throughout the activity. MP4 is to model with mathematics using measurements, organizing data, creating graphs, applying the mathematical reasoning, and evaluate their bridge design. For the 2 science, standards, we're going to define the criteria and constraints of a design problem while considering the scientific principles, and also analyze the data collected during testing to compare design solutions and determine which characteristics leads to the strong design. All right, so our learning objective is that students will work collaboratively to apply the engineering design process to design, build, test, evaluate, and improve the bridge that spans 12 inches and supports the greatest amount of weight. By the end of the lessons, the students will be able to explain the steps that they took in the engineering design process. They're going to apply the mathematical reasoning, collect and analyze all of the testing data, improve their design, and present to the class.
Next is cross-disciplinary STEM learning experience. The process of implementation for this bridge is using the engineering design process, identifying the problem, designing a solution, trial and error, really being able to test that and really make improvements to that bridge. What this connects is science and math, like Lillian talked about earlier, is really those integration of two of those subject matters and bringing them in to be able to make a quality bridge. Properties of different materials pertaining to weight, design, load distribution, and that all falls into the category of incorporating it through technology and engineering. So by researching ideas, building, trial and error, and redesigning based on evidence and really what they see. Lesson implementation. So I'm going to go over the whole layout. So being able to really teach this type of lesson on day one, it's really introducing. And so we really want them to have keywords, talk about vocabulary, talk about challenges that may arise, and really start to form those student groups. Then it comes to the brainstorming ideas and really gathering those materials, because when it comes to the prototype of building that bridge, you have to test it, you have to record the results, analyze that data, and by day 5, it's being able to retest and present those findings to be able to improve bridge quality. For differentiation, I think this is very important because it's supporting all learners through this design process. It's providing visual guides, checklists, teacher modeling. It's encouraging collaboration, and really showing all students can contribute based off their abilities and really what they bring to the table. Also, it's allowing multiple ways of expression, so every student can demonstrate learning while thinking creatively. Challenge advanced students by adding design so you can do constraints requiring additional data analysis and really just start adding on to this bridge.
Okay, so for the conclusion of why this all matters. All right, so the engineering design process helps students become active learners to apply this knowledge instead of simply memorizing it. They're being more active with their learning, and being more active in your learning, you're more able to remember it. So it encourages students to ask better questions, to collaborate better by working together, testing out their ideas, and improving any mistakes that they may have in their thinking through this evidence and this reflection. As teachers, we are to incorporate this engineering design process into STEM instruction because it creates that meaningful learning experience that prepares the students for future careers, whether that be out in any type of workplace setting. They'll have that same type of step and process of thinking and how to solve problems while they're building their confidence, their creativity, and their perseverance. So that is our presentation, and here are our references. Thank you. And cut. Okay, I'm sorry. I thought you were done here, and I didn't know who had this
I'm
slide, so I just took on because
Amani and I
I
looked
was
at
like,
each
we're
other and
running
I was
out of
ready.
time. So I was like, uh-oh. So when y'all looked and laughed, I was
You're
like,
good.
okay.
Yeah.
Did
I
I
didn't
go
put
too fast on
I
this
didn't
one?
point
Were
up
you
here,
able
but
to
I was
do
like
that one?
pointing. I was like, I might, and there. Yeah, I'm glad we're good.
Okay, sorry. I'm so sorry. I'm so
No,
sorry.
It's
you're good.
okay.
Okay,
I
all
think that
right.
was good though.
So
I think that was good.
that was perfect.
Yeah, that was really good.
No, one
I'm
and done. Look at us
satisfied.
Yep.
go.
We
Air
did
fives
that.
all around.
Okay,
Okay.
done.
All right,
I'm
awesome. Okay,
satisfied.
so there's less than a minute. It might shut us out, but
Okay.
I will go.
Hello, my name is Julius Pugh, and I will be describing slide 3 and 4 of the engineering design process. The engineering design process is a student-centered approach that helps students solve real-world problems through creativity, collaboration, testing, and improvement. Unlike traditional lessons that focus on one correct answer, this process allows students to develop and evaluate multiple solutions. The process includes several steps: ask, imagine, plan, create, test, improve, and communicate. Students first identify the problems and brainstorms ideas. Next, they create and test prototype, collect data, and make improvement based on evidence. Almost like the scientific method, right? Finally, they communicate their findings and explain their design through decisions. This process helps students build critical thinking, problem-solving skills, and it helps with collaboration. In the next slide, we will discuss the engineering design process and the implementation of the engineering design process. When implementing the engineering design process, the teacher serves as a facilitator rather than simply providing the answers. We're not here to coach students into the answers. We're here to guide them into finding the correct solutions and finding the correct steps to finding the solutions. Teachers introduce a real-world scenario or a challenge, asking guiding questions, encouraging collaboration, and create opportunities for reflection. Students take an active role by investigating the problem, designing solutions, testing prototypes, analyzing data, and making informed decisions. The key idea is that students learn by doing. Through hands-on experience, they develop STEM knowledge while strengthening important skills such as communication, perseverance, and teamwork. Thank you so much.